The electric field in a region is radially outward with magnitude E is equal to A into R. Find the charge contains in a sphere of radius A centered at the origin. Take A is equal to 100 volt per meter square and A is equal to 20. Right. This is a question. 20 centimeters is there. So how to find the electric field intensity? How to find the charge? We have to find out. So definitely we are going to use this flux E ds cos theta, right? So that will be, if the area is your pi a square, here it is given radius a, so it is E is given A into R, and that integration of ds. Cos theta is equal to 1 because both are having the same direction. So ultimately A into R into area into the integration of area is your this much 4 pi a square. How it comes? 4 pi a square. Here surface area of the sphere is 4 pi r square. Here r is the a. So surface area will be 4 pi a square. That's why integration of ds is your 4 pi a square. So that is the value of the flux. So the charge inside that you have to find out. That is epsilon naught into phi. Epsilon naught, the value of epsilon naught, you have to put it, and first you put the value epsilon naught into phi is your a into r into 4 pi a square. So here 4 pi epsilon naught I have written 4 pi epsilon naught into a into r into a square. Now put the value, whatever the value is there. After putting the value, we know 4 pi epsilon naught is your, we have to write 1 by 9 into 10 to the power 9, because 1 by 4 pi epsilon naught is 9 into 10 to the power 9. So 4 pi epsilon naught is this into a 100 volt per meter square into 0.2 meter square. So if you are going to calculate, you will get 8.89 into 10 to the power minus 11 coulomb. That should be your answer. Another question, important question. A particle is at near point of the charged rod. This charged rod is having the surface charge density, that is sigma is equal to 4 into 10 to the power minus 6 coulomb per meter square. And this one particle is having the mass 5 into 10 to the power minus 6 gram. This charge. What charge should be given to this particle so that if released it does not fall? अगर ये चार्ज कितना चार्ज यहाँ पर दें, यहाँ पर कितना चार्ज दें कि ये इसमें ये गिरे नहीं. If it is released, it does not fall. How many electrons are to be removed? How many electrons are to be removed to give this charge? How much mass is decreased due to this removal of these electrons? That you have to find out. We know in front of the charge sheet, the electric field intensity is sigma by 2 epsilon naught. By putting the different values of the sigma given, sigma is 4 into 10 to the power minus 6 coulomb per meter square, and the value of the epsilon naught, that is 8.85 into 10 to the power minus 12. After putting its value, we will get 2.26 into 10 to the power 5 Newton per coulomb. Right? Now, if now what should be the next point? Now, if the charge is given to this particular point, then the mass is also there, having the mass this. So m into g means weight is going to be balanced with the force exerted. So we have, how we are going to write the equation? Charge into electric field intensity. That is the force experienced on this upward, is that should be equal to the weight of this particular charge particle downward. So that is your m into g. Right? So Q into E, the value of E is 2.26 into 10 to the power 5 is equal to, now m into g, mass of this in gram, we have to convert in kg. So that will be 5 into 10 to the power minus 9 kg into g, 9.8. So that value of Q you can easily find out. 5 into 10 to the power minus 9 into 9.8 by 2.26 into 10 to the power 5. Right, that much coulomb. If you are going to calculate, its a value is you will get, I am calculating with a calculator. That is your 2.21 into 10 to the power minus 13 coulomb. The charge on one electron, now the charge on one electron we know 1.6 into 10 to the power minus 19 coulomb. एक इलेक्ट्रॉन में इतना चार्ज होता है. So कितना the total, so the number of electrons, so therefore number of electrons कितना हो जाएगा? इतना टोटल चार्ज है, इतना एक इलेक्ट्रॉन. So that is the 2.21 into 10 to the power minus 13 by 1.6 into 10 to the power minus 19. That if you are going to calculate, you will get 1.4 into 10 to the power 6. इतना इलेक्ट्रॉन आएगा. That one should be the electron. The mass is going to reduce. So how much mass is? So that will be the mass decrease we have to find out. How to find the mass decrease? Mass decreases. Mass decreased is equal to कितना इलेक्ट्रॉन है? नंबर ऑफ इलेक्ट्रॉन 1.4 into 10 to the power 6 electron into 1 electron is having the mass 9.1 into 10 to the power minus 31 kg. So if you are going to multiply, you will get 1.3 into 10 to the power minus 24 kg. That will be the value of the mass which is going to be decreased. Right?